Hey guys, it's Hink here. I have a very interesting one today. I know some of my audience doesn't like these deep dives into science, but this one is truly integral for understanding penile enlargement. The name of this paper is called Effects of Mechanical Stretch on Collagen and Cross-Linking in Engineered Blood Vessels. So here's the paper here. Now I know that that's a lot to kind of take in, and I promise you guys I'm going to break this down simply and easily for you and how it makes sense and how we can apply it to the enlargement techniques that we have today. So for the background, this study wanted to actually break down what are the effects of mechanical stress on the actual tissues, particularly of blood vessels. So for this study, they were actually using graft tissue. A graft is like artificial cells, or you can have an autologous graft from your own skin graft, for example, or you could have something like an artificial vein. And in this case, that's what they're looking at, is artificial veins. They're trying to figure out what are going to be the best actual grafts to use for vascular surgeries, for example. Why are we even studying vasculature? What in the world does that have to do with enlargement at all? Well, guys, I've said this 1,000 times. I think the process of penile enlargement is more like an aortic aneurysm than it is anything else. Here is the structure of a blood vessel here, okay? I always say, guys, you have the tunica of a blood vessel. So you have the tunica intima, the inner lining, the tunica media, the middle lining, and you also have the tunica external, or the external lining of the blood vessel. And in this particular case, with blood vessels specifically, you have what you call your smooth muscle cells and your endothelium within. Well, the endothelium is the inner lining of the blood vessel, and you have your smooth muscle cells, which are kind of wedged like the sandwich in between. They wanted to study these structures to try to figure out what effect mechanical stretch has and what effect that has on collagen, and how to figure out to make the best grafts that aren't going to rupture. But for our purposes, we care tremendously because guess what, guys? The tunica of the penis is extremely similar to the tunica of the blood vessel, with a couple key differences. There's not quite as many linings. There's really just usually it's just a bi or a two-layered tunica, and in the middle portion there is no the tunica media, which has the actual smooth muscle cells. So a major difference is basically explained within this quote here. First of all, you only have two layers of the actual tunica, and they're kind of arranged in different directions. Guys, if you want me to, leave in the comments if you want me to make an entire video breaking down actual penile anatomy, and I will do so. You know, I like to give the power back to you,
the people.
But as explained in this quote here, you actually have flattened columns or sinusoidal trabeculae composed of fibrous tissue and smooth muscle cells surrounding the endothelial sinusoids. Okay, so what that means is that lining the actual tunica of the penis, you still have these areas of smooth muscle containing tissue that allow for engorgement of blood, and that's where you have your endothelial vessels, guys. I always talk about maintaining the health of the endothelial vessels, the actual inner lining of the blood vessels, because it's integral for not only enlargement, but most importantly for overall penile health and preventing fibrosis. But in this paper, they talk about how the actual collagen is actually secreted from the actual smooth muscle cells. I have to say that there was a big deficit that I had as far as my understanding of enlargement and the actual process behind it, because I understood the dilation, but I didn't really fully understand the growth. And I have to give my hats off to BD, and especially Perv McSwerve or Adam over at Massive Novelties, because on our last live stream we actually talked about this in depth, and the wheels actually started spinning. Here they're actually showing that smooth muscle cells that you have lining these areas are the ones that actually contribute to the collagen. What they say is cyclic stretch has been shown to upregulate collagen and other extracellular matrix proteins in vascular smooth muscle. The smooth muscle is what's going to deposit the extracellular matrix, okay, or the actual structure for growth of the collagen, guys. I hope I'm not losing you. The point is just showing that you need the smooth muscle cells to help to distribute the collagen in this study. The way they did this was they actually harvested smooth muscle cells from the actual pig arteries, okay, and then they used this polymer substance as basically a scaffolding, a frame to attach the smooth muscle cells. And then what they did was very interesting. They did either pulsatile bursts of pressure to represent the different your heartbeat or your aorta at either 0, 90 to represent like an adult heartbeat, or even 165 to represent like a pediatric or a child heartbeat. And then what they also looked at was they increased pressure in increments of 30 millimeters of mercury, because once again, it's very important to denote whether you're using millimeters of mercury or inches. It does matter, guys. And they did these 5-second bursts, and they tried to figure out like what was going to be the actual size that was going to lead to a rupture. Now guys, when we're looking at the results of this study, it is important to keep in mind that this is not true like human tissue, okay? First of all, it's harvested from pigs, but there's some major differences. However, it still has very important insight into the role of collagen, especially when you're talking about the stretch stimulus and rupture. And it is important, guys, always make a big deal out of this, that there's different types of collagen. I think it's kind of, I'm not trying to throw shade, but I think it's kind of like neglectful, I guess, to just say like collagen. Like, you need to talk about what type of collagen it is. In this case, they actually say that most of the collagen that's secreted by smooth muscle cells is type 1 with a minority of type 3. Why this matters is because the corpus cavernosum collagen is predominantly types 1, 3, and 4. So we know that the type of collagen secreted in this study is actually the same type of collagen that we use when it comes to actual enlargement. So what they saw here, which you can see in this figure, is that when you exposed to the different pulsatile rates, different heartbeats, okay, 0, 90 of those little pulsatile beats, or 165, is that either of those, like 90 or 165, is going to increase the actual like collagen wall thickness. But if you actually look on like a histologic stain, the actual amount of collagen, like the collagen density, is actually the same. So you actually are going to thicken the collagen wall, as demonstrated in that picture. So here's where things get interesting, guys. What they found is that the pressure it takes to actual rupture a vein, in this case they looked at the saphenous vein, which is in your calf, and they found that it's about 1,680 millimeters of mercury, or 66 inches of mercury. So that being said, guys, if you go into a pump, like, you're nowhere near actually risking the chance of actually just like flat out just rupturing a vein and like hemorrhaging and just bleeding all into your pump. It's not going to happen. But what they did find, as you can see in this image here, is that the burst pressure that it took, when you had a control study, it was shockingly low. It was about like 13.7 inches of mercury. So guys, that's in a vessel that was never exposed to any kind of heartbeat or any kind of pulsatile force, okay? But what it is showing is that as soon as you increase to like 90 like beats per minute, okay, or that pulsatile force, you automatically increase that pressure from about 13.7 inches of mercury to 18 inches of mercury, or about 458 millimeters of mercury. And then if you increase that beat even more to 165, which was studied, you're looking at about 26 inches of mercury, guys. Kind of interesting. What I take from this, and this is kind of a long shot, is just that the more you pump, there actually is conditioning that occurs, at least in your penile, like vascular tissue. So like the more you pump, the less you're actually at risk of actually damaging your vessels, okay? But also keep in mind that your vessels are always exposed to like your heartbeat, that, you know, that constant pulsatile pressure, which this is kind of mimicking at baseline anyways. Here's a graph looking at stress and strain, and it's not the same type of strain that like BD and like PERV use, okay? It's a different type of strain that they measure as far as the vascular structures. But you can see when you have those actual pulsatile ranges, so either the triangle or the circle, that is going to actually increase the amount of like strain that your tissue can, or the amount of stress that your tissue can tolerate before it ruptures. So guys, before I get to the important takeaways, my course is live, guys. I break down the science in the most time efficient, simple, and easy to follow instructions, all in a video format. There's over 90 minutes of actual video, guys, for only $75. I put a lot of time and effort to it. If you're interested in actually getting bigger and having me easily break this stuff down for you, please check out the link in the description. So what are the takeaways from this study? So number one, guys, these are graphs. Here's an important quote, okay? Our engineered constructs do not contain appreciable amounts of insoluble elastin and the contractility of smooth muscle cells in the vessels, while measurable is less than native. So that's just saying that these tissues do not represent like a one-to-one translation. Take this loosely for like hypothesis generating, is what we say in like the medical field. So number one, we already talked about it. The vessels are not going to rupture, guys. So your D is just not going to explode when you pump the first time. So anybody that's worried about that, get that out of your head. So here's where it kind of gets, this talks about like intervals. And yes, we're talking about the difference between like 90 and 165 beats per minute. But it does make me question if we have 165 beats per minute, that's going to lead to actual like slight thickening of the actual collagen structure and the ability to tolerate higher pressure. Would it potentially be a bad thing to actually have more intervals? I don't know that I believe this, guys. I'm just kind of thinking out loud here. So don't, please, for the love of God, don't, well, BD says to do intervals, but Hink said intervals are bad. No, that's not at all what I'm saying, guys, because it's definitely not a one-to-one translation. It's just kind of interesting that when you're looking at like the collagen response, you are able to tolerate more stress to the tissue with more exposure of that pulsatile in this one graph. So that's kind of interesting. So guys, here's something that's important that as far as I can tell has not really come up, okay? And that's looking at matrix metalloproteinase.
Okay, well, check this out, though. First of all, you're throwing too many big words at me, okay? Now, because I don't understand them, I'm going to take them as disrespect. Watch your mouth.
What is that? MMP. Once again, I want to go on record and say, and I'm the first one on like PE YouTube to talk about this. Correct me if I'm wrong, leave a link to the YouTube video that talks about, but what it is a substance that breaks down those collagen bonds. But what they found in the study is actually that more like increased pulsatile rate, actually the higher the rate of MMP, matrix metalloproteinase, okay? It's kind of like counterintuitive, and they just talk about how it's counterintuitive, but I do think that it's going to be important in playing a role as far as like how we could possibly degrade these collagen bonds. So stay tuned, guys. I still have a full dedicated video on collagen coming. I just wanted to go on record before anybody else got to. So here's another very interesting point. When they looked at the actual like collagen cross-linking, what they found is that there was not increased like collagen cross-linking, but the orientation actually changed to make it a more like circumferential, like around the tube, to allow for more load bearing. Once again, like, what does that mean? What do you take away from it? I don't really know, guys. I mean, like, we aren't necessarily increasing the amount of like collagen cross-linking causing like more stronger fibers this way, but by changing the orientation in this study, they allow it to bear more like load. So just very interesting. Hypothesis generating, guys. And then this is maybe the most important part of this paper here. Callie will put this on the screen for you guys, but it says the mechanical stretch of the ECM, the extracellular matrix or extracellular membrane, is sensed by transmembrane integrins, which relay information to the intracellular region. One of the affected downstream processes is the activations of MAP kinase pathway and the induction of cellular proliferation.
Why don't you explain this to me like I am an 8-year-old?
It basically just means that when you do have that mechanical stretch signal, it does, like we already talked about, actually simulate actual like cellular proliferation.
Why don't you explain this to me like I'm 5?
That's why you can have literally enlargement of your PP without the tunica like thinning and thinning and thinning to the point where it just ruptures, okay? So that is important, especially when we talked about the actual like smooth muscle cells that actually contribute to that collagen secretion. How this plays a role is I'm truly trying to like grasp things like, you know, BPC 157 or even like the P shot, like how they could fundamentally like increase actual penile like size by using it in conjunction with PE. And that's something that I'm trying to figure out for myself. I stumbled across this paper and I thought you guys might enjoy this information as well. I'm going to have a full video out that comes out on PRP and on actual BPC 157. So guys, I thought this paper was really interesting. It certainly helped me to fill in a lot of the gaps. If you need to reach me for direct consultation, you can do so through my Patreon. That's patreon.com/DocHink. Thank you guys for watching. I really appreciate it. Leave a like if you made it this far. Until the next one, guys. Peace and love.